Hey there, this is Mr. Alexander, and today I want to talk to you about factoring third and fourth degree polynomials, which is what we covered in class on February the 2nd and February the 3rd. The first thing I want to talk to you about is a special case third degree polynomial. And in this special case, we're going to use two different formulas, the difference of cubes and the sum of cubes. You're going to use these two formulas when you've got a binomial. Binomial is two terms. 2, 2, 2, and that binomial is comprised of two perfect cubes. So let's talk about what perfect cubes are. Like, the first perfect cube is 1 to the third power, which is 1. Second perfect cube is 2 to the third power, which is 8. 3 cubed is 27. 4 cubed is 64. That's 4 times 4 times 4. 5 cubed is 5 times 5 times 5 is 125. 6 cubed, 6 times 6 times 6 is 216. Those are perfect cubes, and of course they go on from there. I know these are perfect cubes because 64 is 4 cubed, and x to the third is just x times x times x. So the first thing you want to do is rewrite this thing as x cubed plus 4 cubed. Now if you look up at this formula, we've got an a and a b. Our a equals x, and our b equals 4. And all we're going to do is rewrite this guy using this formula. So it's going to be a plus b, because this is the sum of cubes. A plus b, so x plus 4. And then over here we've got a squared, so x squared. Minus ab is minus 4x, and then plus b squared, so plus 4 squared, which is 16. And that's it. You'll never be able to factor this term further. So this is the fully factored form of this binomial. So we got one factor with an x and one factor with an x squared. We're going to do the same thing here, but now this is the difference of cubes. So this is x to the third minus 4 to the third. So it's the exact same thing. We've got our a equals x and our b equals 4, but now we're going to use this formula. So we've got x minus b, or a minus b, which is x minus 4, times a squared, which is x squared, plus a times b is 4x, plus 16, which is b squared. Now, the difference between these two things is just a couple of signs. This one's a positive, this one's a negative, this one's a negative, this one's a positive. The way you can remember which one's which is if you're dealing with a positive or negative, remember SOAP. SOAP stands for same, opposite, always positive. So since this one is a minus sign, we had a minus sign first. Same. Then a plus sign. Opposite. Then a plus sign. Always positive. Over here, this one started with a plus sign. Same. Opposite. Always positive. Plus, minus, plus. Minus, plus, plus. Let's talk about one more sum of cubes. So here, this is 2x cubed, because that 3 in the exponent distributes to the x and the 2, plus 3 cubed. So my a equals 2x, and my b equals 3. So this time I'm just going to write in the numbers, and I'm not going to worry about the signs until the end. I know I've got my a something b, a squared, because 2 squared is 4, a times b, 3 times 2 is 6x, and then b squared is 9. Well, how do I know if they're pluses or minuses? Remember SOAP. Got a plus sign, so it's the same, opposite, always positive. Okay, that's enough of the special case. Let's just get down to some basic factoring. And I want to talk about third degree polynomials first, and then we'll talk about one fourth degree polynomial. The good news is the process is nearly identical. So I'm looking at this n cubed plus 8n squared plus 12n, and I am supposed to factor this expression. Well, the first thing I always do is look for the greatest common factor. What do n cubed, 8n squared, and 12n have in common? Well, they all share an n. So I'm going to go ahead and factor out that n to start with. And in parentheses, I'm going to write what's left. I took an n out of n cubed, so that's n squared. I took an n out of 8n squared, so that's just 8n. And then 12n divided by n is just plus 12. So I need to do something with this. I can factor this further. And the way I like to think about this is I'm looking for two numbers that multiply to 12 but add to 8. So they multiply to 12 but add to 8. So I think of all the factors of 12. So that would be 1 and 12, 2 times 6, 3 times 4. Which one of these adds to 8? This is 13, this is 7, this one's 8. So the fully factored form here, I'm going to keep that n out front, but then I'm going to write this term as n plus 2. That's that 2 right there, times n plus 6. This is the fully factored form of that third degree polynomial. And some of them are that easy. Not all of them are. The next one we're going to do is not that easy. But sometimes it's easy to factor them. Sometimes it's more difficult. Like in this next example. So I've got 6y cubed plus 21y squared plus 18y. And I'm thinking of greatest common factors. Well, I see that they all share, although they share any, yes, they share a 3 as a factor, and they share a y. So I'm going to factor out that 3y. 6y cubed divided by 3y is 2y squared, because 3y times 2y squared is 6y cubed. I took a 3 out of 21, so 21 divided by 3 is 7. Y squared divided by y is y. 18 divided by 3 is 6. Y divided by y is 1. So now I've got this thing on the inside here that I'm going to have to factor a little bit differently. And for these kinds of problems, I like to use the box method. So I'm going to draw myself a little 2 by 2 box here. In the top left-hand corner, I'm going to write that 2y squared. In the bottom right-hand corner, I'm going to write that 6. Question is, where do I write the 7? And the answer is nowhere. I'm not going to write that 7y anywhere. Instead, what I'm going to do is I'm going to say, okay, a times c, 2 times 6, is 12. What are all the factors of 12? Well, there's 1 and 12, there's 2 and 6, there's 3 and 4. I'm looking for the one that adds to 7. So this is 13, this is 8, this is 7. This is going to tell me how to divide up that 7y into 2 boxes. Instead of writing 7y in one of the boxes, I'm going to write 3y and 4y. And from here, you just have to ask yourself 4 questions. The first one is, what factors do these 2 boxes have in common? They've got a 2 and a y. I'm going to write the 2y on the top there. What factors do these have in common? Well, they share a 3. These 2 factors share a 3. There's a plus sign in between. Okay, what do these 2 factors share in common? Just a y. And what do these 2 factors share in common? Looks like they share a 2, a positive 2. On the outside of the box here, I've shown myself how to fully factor this guy. I've still got the 3y. But now I've got a 2y plus 3 and a y plus 2. Let's do that again with a fourth degree polynomial. So this guy right here. 30h to the fourth plus 25h cubed minus 5h squared. Well, the common factor they share seems to be a 5 and an h squared. All right, 30 divided by 5 is 6, and I took two h's out, so I've still got an h squared. 25 divided by 5 is 5h, and then of course 5 divided by 5 is just 1. H squared divided by h squared is also 1. So I pull out the 5h squared. So this fourth degree polynomial thing is not that different from the the third degree is not that different from the fourth degree. And again here, I'm going to use the box method. So I'm going to make my box, 2 by 2 box. I'm going to put my 6h squared, I'm going to put my -1. And I'm kind of wondering what to do with the 5h. Well, I'm going to take a times c, which is 6 times -1, which is -6. What are all the factors of -6? Well, there's -1 and +6, +1 and -6, -2 and +3, +2 and -3. And I need to know which one adds to +5. Well, hopefully you can see it's that first one we did. -1 plus 6 equals +5. So that's how I'm going to divvy up my box here. I've got a -1h and a +6h. What do these two have in common? They have a 6h in common. What do these have in common? -1. What do these have in common? H. What do these have in common? +1. You may not see that. This is actually -1 times +1. So that's why they have a +1 in common. So the fully factored form, I've still got that 5h squared. And then I've also got 6h minus 1 and h plus 1. So this is the fully factored form here. And last thing I want to show you, very last thing, is a deceptively simple fifth degree polynomial, just to show that you can do it. So ask yourself the same set of questions. What's the greatest common factor here? Well, they share a 2, and they share an h. And that leaves me with 49 h to the fourth minus, well, that's just 1, isn't it? So I've got the 2h, and whether you realize it or not, this is actually the difference of two squares. Difference of two squares. So that means I can write this as plus and minus. And the numbers I write in here, square root of the first term, square root of the second term. So the square root of 49 is 7. The square root of h to the fourth, h squared. Square root of 1, it's just 1. Square root of 49, 7. Square root of h to the fourth, h squared, square root of 1. Now I knew that was the difference of two squares because that's a perfect square, that's 7 times 7. That's a perfect square, that's h squared times h squared. And that's a perfect square, that's just 1 times 1. So the fully factored form of this fifth degree polynomial, 2h times h squared plus 1 times 7h squared minus 1. That's it.